Travelling out from the sun, try to identify the planets in our solar system. Nine planets, all spinning through space as they revolve around the sun. But how do we know what the planets look like, how they move, and how they differ from the billions of stars which lie beyond? The best way to build up a picture of the solar system is to start by making observations.
We've got to find a good place to set up camp so we can get nice and comfortable, because I don't know how long we'll have to wait. OK, this looks like a good spot.
So we've come a long way.
Yeah, we have come quite a way up, haven't we? But the idea of that is we need to get away from the bright lights of the towns and cities. Because when you're looking at the stars, if you've got bright street lights around, you won't be able to see them very well. Right, if you sit back and look up at the sky and open your eyes, see what you can see. Just wait a minute, wait for your eyes to adjust.
What's that bright star over there?
Right, that's not actually a star, Matthew, that's Venus. You know that's Venus because it's the brightest thing in the sky. You may think it's a star because it does look like one, doesn't it?
Yeah.
But you see, stars have their own light source, whereas Venus is a planet, so it reflects the light from the sun, just like the moon does.
Each star is like our sun, constantly giving out huge amounts of light, only they're millions and millions of kilometres away. Stars look like points of light, even through binoculars. If you look carefully at this magnified view of planet Venus, you can see it isn't a point of light, it's crescent-shaped. We see Venus and the other planets in the same way as we see our moon. They're lit up by the sun. The shape we see depends on how much of its surface is reflecting the sun's light back to us.
What other planets can we see tonight?
Right, well, tonight we should be able to see Jupiter. If you take a look up there, you can actually see Jupiter. It's not quite as bright as Venus, but it's still one of the brightest things in the sky. Now, if you get your binoculars, you take a look, you should be able to see the moons of Jupiter. The Earth isn't the only planet with moons. You see, Jupiter's got moons, as have a lot of the other planets.
God, it looks brilliant, isn't it?
And if you can lay your hands on a pair of binoculars, a look at our moon is definitely worth it.
Can see the craters really well.
The detail is amazing. For thousands of years, civilizations all over the world have been fascinated with the way the stars and planets appear to move across the skies. But before binoculars and telescopes, only simple observations could be made. The Mayans in Central America observed the planets through buildings pierced with tiny holes, using the patterns they saw to devise their own calendar. At the other side of the globe, Arabic astronomers carried out a detailed study of the stars, naming them and cataloguing the changing positions throughout the year. Most early cultures had the same view of the universe, that the Earth was perfectly still, explaining the motion of the stars, planets and sun by assuming they all moved around the Earth, often using fantastical stories to help explain their observations. Ancient Egyptians believed that the sun god Ra rode the sun across the sky in the daytime, rowing it back under cover of darkness to start again the next morning. It wasn't until thousands of years later, with the invention of the telescope, that people's views of what the universe looked like began to change.
My name is Galileo Galilei, and my story takes place at a time when nobody really knew how the universe worked. A Greek teacher called Aristotle said that the Earth stood still and that the planets and the sun moved around it. It was not until 1543 that a man called Copernicus said that the sun stood still, not the Earth, and that the planets and the Earth moved around the sun. I was born 21 years later and tended to believe Copernicus. But I needed evidence to prove him right.
Oh, it's no good. Oh, it's no good. Oh, the frustration of it. If only I could position the lenses to magnify enough, I would have a device which would enable me to see further into the skies. So, it depends on which lens I choose and how close I place them together, like so. Oh, Mamma Mia! I have it! A proper telescope! Mamma Mia! I have seen millions and millions of stars, all so bright. And then I saw the planet Jupiter with moons next to it. Now, Aristotle, he said that everything goes around the Earth. But I watched night after night and saw these moons move around Jupiter. Proof at last that not everything goes around the Earth. Now, the Catholic Church believed that the Earth had to be at the center of the universe. So when they read my observations, they banned me from writing. Years passed, and I couldn't contain my discoveries any longer. I had to write. Well, when the Church heard about my next book, they summoned me to Rome for sentencing.
Galileo Galilei, you must accept the teachings of the Church and of Aristotle. You must accept that the Earth is at the center of the universe. You are ordered to house arrest and forbidden to speak of your views again.
Locked away from the world, my telescope was my only joy. What I hadn't realized was that looking at the sun directly would make me blind. As a blind man, my dream was always the same, that one day my telescope would be used to unearth the secrets of the universe.
Thankfully, Galileo's work wasn't in vain. The telescope allowed more accurate observations and discoveries to be made. Until eventually, it became clear that the Earth and the other planets do in fact move around the Sun. At last, scientists were able to make sense of the way the Sun, planets and stars appear to move across the sky. As the Earth orbits around the Sun, it spins, making one full rotation every 24 hours. That means the Earth rotates at 30 kilometres a second. Imagine you're standing on the Earth and looking at the sky. During the day, you're facing the Sun. As the day progresses, it looks as though the Sun is moving, when in fact it's perfectly still. At night, you're facing the stars. As the Earth spins round, you pass by the stars, which makes it look as though they're moving. So why isn't it strictly true to use terms like sunrise and sunset?
Hello, 11, this is Houston. We confirm ignition and the thrusters go. Here comes the shadow. Houston, the Eagle has landed.
On the 20th of July 1969, Neil Armstrong was the first man to walk on the moon. After years of research by rocket engineers and scientists trying to develop a spacecraft capable of going to the moon, the Apollo 11 mission was a major achievement. It's only over the last 40 years that we've had the technology to explore the solar system. Spacecraft and probes have sent back detailed information and images, giving us a clearer picture than ever before.
If you're planning a journey into outer space, here's a quick summary of the conditions to expect over the next few billion years, starting with our local star, the Sun. Nuclear reactions converting hydrogen to helium constantly give out huge amounts of energy. With a surface temperature of 6,000 degrees Celsius, a trip to the Sun is too hot to handle for all but the best protected space probes. Mercury rotates very slowly. The side pointing away from the Sun drops to minus 180 degrees Celsius. Facing the Sun, temperatures rocket up to a sweltering 400 Celsius. Venus is hot property too. It's further out from the Sun than Mercury, so you would expect it to be cooler. But a deadly atmosphere of carbon dioxide and sulfuric acid creates a greenhouse effect, boosting its temperature to 470 Celsius. That's hot enough to melt lead. Earth's greenhouse effect isn't as extreme. It's only slightly warmer than you'd imagine, averaging a comfortable 14 Celsius. Liquid water and an atmosphere able to support life make Earth unique. Mars, on the other hand, has hardly any atmosphere at all. Far from the Sun, its temperatures plummet way below zero. Its ice caps are a mixture of frozen carbon dioxide and water. Now, moving much further out, Jupiter is the biggest planet in the solar system. It's made up of swirling gases under enormous pressure. Tremendous storms constantly sweep across its surface. Saturn is similar to Jupiter. Both have an intensely hot, rocky core, which throws out more energy than these planets receive from the Sun. Uranus is much colder. It's an icy minus 200 Celsius. Not a place to visit unless you have to. Neptune, the final gas planet, is colder still and boasts the fastest winds in the solar system, with gusts clocking in at over 2,000 kilometres an hour. Further past Neptune is the smallest planet, Pluto, which we know least about. It's so far away that no space probe has ever reached it.
So maybe space travel isn't quite so practical after all. The solar system is huge, almost too huge to imagine.
We're making a model of the solar system.
We've worked out on our scale that if the Sun is this big,
The planets would look like this. Mercury.
Venus,
Earth. Mars.
Jupiter,
Saturn, Uranus,
Neptune.
Pluto.
and on this scale, the distance between the Sun and the furthest planet, Pluto, would be 3 kilometres.
And so we need a really big space. A really, really big space. And a little bit of help. Bye, Sam!
If the Sun's the size of a large beach ball,
Mercury!
Mercury's a coriander seed.
Venus!
Two planets almost identical in size are Venus and Earth.
Earth!
They're both as big as a black currant. Is the size of a peppercorn.
Jupiter!
Jupiter, the biggest planet, is still only the size of an orange.
Saturn!
Saturn's the size of a lemon.
Uranus!
Uranus and Neptune are about the same size as each other.
Neptune!
They're the size of a large grape.
Pluto! That's me!
And Pluto is a tiny onion seed. On this scale, you can see how the four inner planets are quite close together. But after Mars, the distances between the planets gets much bigger. Jupiter is 778 million kilometres from the Sun. Saturn is 1,427 million kilometres from the Sun. Uranus is 2,871 million kilometres from the Sun. Neptune is 4,497 million kilometres away, and an amazing 5,914 million kilometres from the Sun is Pluto. And I'm off to the nearest star, Proxima Centauri, which on this scale is somewhere in Australia. See ya. Our knowledge of how the planets stay in orbit around the Sun is largely down to Isaac Newton. In 1666, Isaac Newton was thinking very hard about why things fall down instead of up. He came up with the idea of gravity. He decided there was an invisible force of attraction between any two objects. But that the larger the objects, the greater the attractive force. This means that although small things are attracted to each other, the attraction is so small we don't really notice it. Because the Earth is so huge, things are pulled to the ground when we let go of them. This is because they're attracted to the whole planet. Newton realised that the pulling force depended on the size of the planet. Mercury is smaller than Earth, so the pull of gravity is less. And on bigger planets, the gravitational force is greater. Jupiter is over 300 times bigger than Earth, so imagine what the gravitational pull would be like. He also worked out that the further away from the planet you are, the smaller the pull of gravity. The Sun is the biggest object in the solar system. It's more than 1 million times bigger than the Earth, so its gravitational pull is big enough to influence all 9 planets, keeping them in a nearly circular orbit. It's a bit like a hammer thrower, keeping the hammer moving in a circle. The person in the middle represents the Sun. The tension in the chain is like the force of gravity. The hammer is the planet. What would happen to the planets if the Sun's gravity disappeared? It isn't just dedicated stargazers that come out at night. This strange object, hiding in a shed on the Yorkshire moors, regularly strikes into action. It's a robotic telescope, the only one of its kind in the world. Which means that you can sit back and take a look at the night sky from the comfort of your own home or school. All you need is a computer and access to the internet.
You can see why they call it that, can't you?
Information on every planet and star constellation is available at the push of a button.
It's a comet and it's just gone spinning round.
And if you want to put in your own request, simply type it in during the day.
Planet. And if you submit these details.
And let the telescope do all the hard work in the middle of the night.